Okay, in this section we are going to take a look at certain things. One is how we divide polynomials, and after that we are going to take a look at the remainder and factor theorems. For the divisions, there are two kinds. One is long division. The long division is very similar to what we divide for numbers. For instance, let's recall how we divide numbers. Okay, 6 5 0 3 5. Okay, 65,035, and we are going to divide by 320. Okay, so how we divide that? We put that dividend inside the division box, divisor outside, right? We check. Okay, 1 2 3. Let's see, do we get into that 2? So that's 640. Then we do subtractions and 110 and bring the next term down. That's 3. Do we have enough? No. Bring another term down. So that will be 0, right? So that will be let's see, 3. So that is 940. Subtract them. So that's 5, and that will be 9, right? 95. So we say that this is 203 with remainder 95. I'm using that just helping you to think about polynomial functions. Is the polynomial function is the same thing if we are going to use 6x4 plus 5x cubed plus 3x minus 5. If we use that to divide by 3x squared minus 2x, we are going to do exactly the same as before when we did that long division for number, because this is 10,000. That's 6 times 10 to the 4 power. You can relate to 6 to the x4. So what we are going to do is put down the dividends inside division box and keep the space. For instance, x cubed, we don't have x squared. I'm going to put 0 x squared, keep the space in here, plus 3x minus 5, and using that to divide by 3x squared minus 2x. Similar things. We are going to use the first one. Okay, divide by this one. Let's see what we get. 6x4 divided by 3x squared. So what I get is 2x squared. Okay, so that we go to your quotient, so that the division part of 2x squared. So the next one, we are going to multiply using what you found for the quotient times the whole divisor. So 2x squared times 3x squared minus 2x in here. When you multiply it out, distribute that inside, what I got in here is 6x4. We are expecting to get the first term is exactly the same, so we can subtract them, and that one is minus 4x cubed. So the whole thing we are going to subtract. 6x4 subtract 6x4, that's 0. 5x cubed subtract minus 4x cubed, that will be 9x cubed. So the next thing we are going to do, bring it down, the next term, with plus 0x squared. Let's see if we have enough to would divide or not. So you have what? 9x cubed divided by 3x squared. So what we have in here is 3x. So that we go to our quotient plus 3x. Similar idea. I'm going to use 3x times the divisor. So that will give me 9x cubed minus 6x squared. Okay, subtraction. Subtract that, so that one be 0. 0 minus negative 6, that's positive 6x squared. Again, we are going to bring the next term down. Plus 3x. Let's see. X squared still the same degree. I can divide that. So we are going to use 6x squared divided by 3x squared, that give me 2. So that we go to my quotient, so that is plus 2. Okay, so using 2 times the divisor, so that will be 6x squared minus 4x. We are going to subtract that, so that's 0. 3x minus negative 4x, that's 7x. Bring the next term down, minus 5. Well, this one, degree is less than that, just like your remainder is less than your divisor. So this is your remainder. So what's the solution will look like? So the solution is equals to 2x squared plus 3x plus 2, that's your quotient, plus the remainder 7x minus 5 over 3x squared minus 2x. Okay, so that is called long division. And with here you can see I have divisor, dividend divided by divisor is equal to quotient plus remainder over the divisor. In this called division algorithm. So what it say that if you have f of x and d of x are polynomial with d of x is not equals to 0, and the degree of d of x is less than or equal to the degree of f of x. Okay, so then we say that there exists a unique polynomial q of x and r of x such that f of x is equal to d of x times q of x plus r of x. What it is related to what we learned in the division. We say this is the dividend is equals to the divisor times the quotient plus the remainder. So with the example before, in here we can say that 6x4 plus 5x cubed plus 3x minus 5, in this is equal to the divisor times the quotient we found plus the remainder. Alright, if this equation is not true, then the answer we found is not correct. I'd love you to check that. And one of the special case is when you have your remainder is equal to 0, which is in number we say that divided evenly. The same thing in the polynomial function, we say that d of x divides evenly into f of x. So which means that you have f of x is equal to d of x times q of x. Well, that one you can see is a factors, right? So therefore we say that d of x and q of x are factors of f of x. Okay, so that is the long divisions. And let's take a look at another one. Okay, so let's see. We have sorry for that. I think I got something wrong with my computer. So let's see. 5x cubed plus 6x plus 8 divided by x plus 2. Okay, so let's perform these divisions. The same thing, using your dividend inside the division box and keep the space for the missing term, like x squared is missing term. And this one is divided by x plus 2. So 5x cubed divided by x, that's 5x squared. 5x squared times x plus 2. So we get 5x cubed plus 10x squared. Subtract them. 0, negative 10x squared. Bring the next term down, plus 6x. Let's see. Less than degree than that, we can continue division. Negative 10x squared divided by x, negative 10x. So multiply negative 10x squared minus 20x. Subtract them. So that's 0. That one's plus 26x plus a. 26x divided by x, that's 26. 26 times x plus 2, that's 26x plus 52. Subtract them. 0, that is negative 44. Well, this degree is certainly less than that. So therefore, that's equals to 5x squared minus 10x plus 26 minus 44 over divisor x plus 2. That's long division. Indeed, this is special kind of divisor, so that's called linear divisor because the degree is 1. When a linear divisor have the linear divisor, we can use another kind of division called synthetic division. How that work is, first, you need to make sure the divisor is of the form x minus c. Okay. Let's take a look at this one. Okay, for the same example, and if we take a look at the divisor, is x plus 2. So let me write it as a subtraction. That will be x minus negative 2. So that one, this is your c. So how the synthetic division work is going to put down all the coefficients of each term. Right? Take a look at those coefficients. So I'm just going to write 5 extending y 5x cubed. 0, that's the coefficient x squared. 6, that's coefficient of x. A is the constant. And I'm going to put the c right here. So the c is negative 2 in this case. So vertically, we are going to add 5 plus nothing, that's 5, right? And then we go diagonally, is you multiply by the c. So in this case, the c is negative 2. 5 times negative 2, that's negative 10. 0 plus negative 10, vertically add this addition, negative 10. Times negative 2 because they multiply by the c, so that's 20. Vertically adding 26 times negative 2, negative 52, so that's negative 44. Right, so this will be your remainder. Right, with the remainder, the next one will be what? Constant. And this is x coefficient, this x squared coefficient. So therefore, you can get coefficient of x squared, that's 5x squared minus 10x plus constant and remainder over the divisor. And you can see we can get this exactly the same solution as above. Now let's take a look at another one, a fresh one, to see how this synthetic division works. we have x squared minus 6x minus x cubed plus x4 divided by 6 plus x. Alright, so this one is written a little bit messy. Let's fix that. We are going to write this in the descending order. So that's x4 minus 6x cubed plus x squared minus 6x. That's divided by x plus 6. Okay. Again, x plus 6 can be written as x minus negative 6. So in this case, we got this c is negative 6. So we are going to put down all the terms. x4 coefficient is 1, x cubed coefficient is negative 6, x squared coefficient is 1, x coefficient negative 6. Okay, don't stop in here, because if you stop in here, this is different, because this is constant. X squared, x cubed is different from here. So we need to put the 0 for the constant. Don't miss any term. Just like you write 10 is 1 0. You cannot just write 1. Because you write 1, that's number 1 is number 10. Alright, so the c in this case negative 6. Alright, vertically at 1. Diagonally multiplied by c, negative 6, negative 12, adding them, times negative 6, that's positive 72, that's 73, 73 times negative 6, that will be negative 438, right? Add them together, so negative 444 times 6, that is positive, okay, 444 times 6, that will give us 2,664. So add them, so 2,664. So what's the solution? Remember, this is remainder. So remember, I'm going to write remainder over the divisors x plus 6. This is constant minus 444. This is coefficient of x, so 73x, that's coefficient of x squared. And this coefficient of x cubed. And you can see it's 1 degree less than the before. Okay, so that is the solution of this division. Something is interesting about this remainder. We have a theorem called remainder theorem. What this theorem telling us is the remainder you found from the synthetic division indeed is the function value at the c point. If the polynomial functions f of x is divided by x minus c, then the remainder is f of c. Okay, so what it meant in here is, going back to the example I have in the last page, if I say that f of x is equal to this dividend, which is equal to x4 minus 6x cubed plus x squared minus 6x. Okay, if I evaluate f of negative 6, well, by the function definition, that's the same as negative 6, 4 minus 6 times negative 6 third plus negative 6 squared minus 6 times negative 6. After you do the evaluation, indeed, this is exactly the same as this one, which is 2,664. You can plug that into your calculator to take a look if that's true or not. So that's very neat, right? Okay, let's take a look of another theorem, which is what happens if your remainder is 0. If your remainder is 0, we say that, well, is f of x is dx times q of x. So that is the factors. So we call this is the factor theorem. what it meant is, if we have f of x is a polynomial, if we say f of x is equal to 0, we call that the 0, right? So f of x, f of c, let me call this special one, f of c. Then we say x minus c is a factor of f of x. So this is a two-way street. If you have x minus c is a factor of f of x, then f of c equals 0. Let's see the example. Okay, we are given function f of x is equal to 2x4 minus 5x cubed minus x squared plus 3x plus 2. We are going to find f of 1/2. All right. In order to do that, before today's lesson, the way we do evaluation of the function is f of 1/2 is equal to 2 times 1/2 to the 4 power minus 5 times 1/2 cubed minus 1/2 squared plus 3 times 1/2 plus 2, right? Whatever one you get. But today we can take advantage of the synthetic divisions, okay, to find, or using the remainder theorem. What we can do is, okay, put in coefficient of these functions. So there's 2, -5, -1, 3. There's nothing missing, right? 2. And synthetic division, the c is 1/2. Vertically, add, diagonally multiply by c, 2 times 1/2, that is 1. -4, -4 is times 1/2, that's -2. -2, add -1, -3 times 1/2, -3 half. Okay, 3 plus -3 half, that's the same as 6 half minus 3 half, that's 3 half again, times 1/2. That will give us 3/4. Okay, so if we have 3/4, so that will be 11/4. Let's double check my calculations. 2, -5, -1, 3, 2. Alright, so nothing wrong with that. Vertically 2 multiplied by 1/2, that's 1. So -4, -4 times 1/2, -2, plus -1, that's -3. -3 times that -3 half plus the 3, that is 3 half. 3 half times, so that's 11/4. Alright, so let's check. If you check this one, that means f of 1/2, that's equal to 11/4. You can check this one. This one should be 11/4. Okay. Alright. Let's see another one. So this is how we use the remainder theorem. And we are going to find all zeros of f of x equal to x cubed minus 4x squared plus x plus 6. And we are given the informations. -1 is a 0. Well, what does that mean? -1 is a 0. Okay, so that will mean that f of x is equal to, by the factor theorem, is equal to x minus -1 times something. You can factor out completely. What's that something? We can use a syntactic division to find out what the something is. Excuse me. So we are dividing -1. Okay, so we have 1, -4, 1, 6. Okay, c is -1. Bring the 1 down. -1 plus -4, -5. So that's 5, 6, 6, -6, 0. See, it's a 0. That means that is f of -1. That's correct. It's a 0. So this part is your quotient. What's the quotient means? X squared minus 5x plus 6. So which means this question mark is x squared minus 5x plus 6. So when you find the zeros of a functions, that means f of the x value. Oh, sorry for this. We caused f of x equals 0, which in this case you have x cubed minus 4x squared plus x plus 6 equals 0. Well, in this case, f of x can be written in here, so the whole things become x plus 1 x squared minus 5x plus 6 equals 0. So that by the zero factor property, you get x plus 1 equals 0, which is x equals -1, which is what we are given. -1 is a 0. And on that other side, that you have x squared minus 5x plus 6 equals 0. If we use factoring, that's x minus 2, x minus 3 equals 0. So you have x equal 2 or x equal 3. Right. So you have the zeros are -1, 2, 3. You have 3 zeros in here. Okay, so that is the divisions for the polynomial functions. In the next sections, 2.6, you will see more of this syntactic division and how to link into the zero of the polynomial functions. Okay, I see you in the next sections.